Up to this point, we have focused on value at risk, which defines a loss threshold at a chosen confidence level. However, VaR deliberately ignores what happens beyond that threshold. In this section, we'll explicitly analyze tail risk, focusing on the worst losses in the return distribution. Tail risk refers to the behavior of returns in the extreme left tail of the distribution. Instead of asking where losses start, as the VaR does, tail risk asks, how bad are losses once things go south? This distinction is critical for understanding severe market events. Here, we define the tail as the worst 1% of daily returns. That corresponds to a tail quantile of 0.01, meaning we focus only on the most extreme 1% of outcomes in the dataset. Let's walk through the tail risk table column by column. The tail cutoff is approximately minus 3.08%, which corresponds to the 99% historical VaR we computed earlier. Any return worse than this cutoff is classified as a tail event. The average tail return is approximately minus 4.42%. This tells us that, conditional on being in the worst 1% of days, losses are substantially larger than the VaR threshold itself. The minimum tail return in the sample is around a mind-blowing minus 10.94%, representing the single worst daily loss observed. Think about that for a second. That means the S&P 500 dropped by over 10% in a single day. Finally, we have 41 tail observations, which is consistent with taking 1% of roughly 4,000 daily returns, as you saw in the section before. This comparison highlights a fundamental limitation of value at risk. VaR tells us where losses begin to get bad, but it tells us nothing about how bad they can get. In this case, the VaR cutoff is around minus 3%, but the average tail loss is closer to minus 4.5%, and the worst observed loss is far larger. This gap between VaR and tail outcomes is exactly why VaR alone is insufficient for managing extreme downside risk. The histogram on screen shows the distribution of tail returns only, meaning returns worse than the tail cutoff. You can see that even within this extreme subset, losses are not uniform. Some tail days are moderately bad, while others are dramatically worse. This dispersion illustrates that extreme losses are themselves variable and difficult to model with simple assumptions. Importantly, the histogram does not tell us when these events occur, only how severe these are once they happen. In practice, tail risk measures are used to complement the VaR. They provide information about loss severity and help risk managers understand potential capital impacts during extreme market conditions. Tail risk analysis is especially important for portfolios with leverage, nonlinear payoffs, or exposure to crisis-driven correlations. Having analyzed tail losses empirically, we will now move to stress testing, where we examine portfolio losses under hypothetical market shocks rather than relying solely on historical data.